everybody, I'm Saha Tayyib, MedEd intern, and we interns are back with another video series, this time covering biostats.
So in this video, we will be talking about normal distribution curve. So normal distribution curve is also known as the Gaussian curve and the bell curve. We will talk about its characteristics. Before that, have a look at this graph. Its x-axis denotes standard deviation and y-axis has population density on it. Right. So it is a bell-shaped curve. Asymptotic, that means it does not touch the x-axis, and it could never touch the x-axis because our population density cannot go down to 0 when we're plotting. Bilaterally symmetrical, so if we were to draw a line of symmetry in the center, it would show that both halves are equal. Total area under the curve is 1, and that's important when we are plotting our normal distribution values. The mean, median, mode are numerically equal and equal to 0. So what that simply means is that this is a normal distribution curve. It has been standardized, and our standardization includes mean being denoted by 0. And the values are accordingly adjusted to it, as we'll see ahead. So this is how 0 would denote our mean because it's been standardized. And on either side, the 1, 2, 3 plus or minus would show us our standard deviation. Now, standard deviation rule is that one standard deviation would have 68% of the data in it, or would include 68% of the population. So that would mean on either sides, plus minus, we'd have 34.13% represented on either side. So a total of that would be 68. Now, two standard deviation would mean that 95% of the data would lie within two standard deviation. And that would mean on either side, we have 13.59%. But above, when we're considering from mean, which is 0, we'd have plus minus 47.5% of data on either side. And then 3 standard deviation would mean that 99.7% of the population would be included within this, around the mean. So that means on either side, that'd be 2.14%. Between the second and third deviation, but as a whole on one side that'd be 49.6% on either side of the mean. So our mean is also denoted with the symbol mu and standard deviation with the symbol sigma. Now that's important ahead. Okay, use of normal distribution curve. So bell curves are used to portray data that is used in everyday life. And this could include test scores, height, weight, blood pressure, any continuous data. So let's take an example of test scores. So we see that most of our data is condensed around 60. That means if we were to calculate our mean of this data set, our mean would be 60. So what we want to do is standardize it. And when we standardize it, by calculating our mean and standard deviation and plotting it on the curve, this is what the curve should look like. So 60 would become 0, and our standard deviations would be plotted accordingly, and this would give us a bell curve of. Now we'll be using this in Excel and generating a normal distribution curve with our sample data. Here is our Excel sheet. And so Microsoft Office, a quick intro into it is a spreadsheet software wherein we can organize our data in rows and columns. Our columns are labeled by alphabets over here on top, as you can see, and our rows are labeled by number. And each box over here represents a cell, and each cell has a cell label, name, or a reference So this highlighted box over here lies in column A, row 1, hence it's called cell A1. Another thing is that in Excel, all the formulas begin with an equal to sign. So, okay. So this is a data set, and we will be calculating our mean, standard deviation, normal distribution curve, and in fact, generating a normal distribution curve. So let's start with calculating our mean. To calculate mean, type in equal to average, because mean is the average of data set, open parenthesis. Select my data range. So my data of interest is to do with heights only. So I'm going to select my heights, close my parenthesis, click enter. And my mean is 165.5. Let's calculate standard deviation. Type in equal to STDEV bracket or parenthesis. Select my data, close my parenthesis, press enter. So that is my standard deviation. For my ease and preference, I'd like to take down my values into decimal places. So I'm going to go over here and click on it till it's 2 decimal places. There we go, easy. Now, once we're done with that, we know our mean, we know our standard deviation. Now I need to standardize my observations, my height values over here. If you remember, we talked about standardizing our values around mean. So mean over here is 165.5, which means on a normal distribution curve, it would be labeled as 0. And a standard deviation is 9.85, so that's one standard deviation. And double of that would be 2, so that's how it'll be labeled on our curve. So when we want to plot our data on that standard normal distribution curve, I would want my values to be standardized as well. So this is the formula to standardize our values. That is x being our raw score, subtracted from mean or mu, and divided by standard deviation or sigma, and that would give us my z value, which is my standardized value. I'm going to type equal to, in parentheses, I'm going to be doing raw score minus mean. I'm going to select my mean, close my parentheses, divided by standard deviation. My standard deviation is here, so I'm going to select this cell. Now, before I press enter, this is really important that we will be making our life way more easier, and doing an autofill function will help us save time. And instead of me having to type all of this over again for each of the cells, it's going to just copy the formula and give us the answer according to each value. So to be able to do that, I know that my values of mean and standard deviation would remain the same. So I want to lock those values in, while my value for height would keep changing in each cell. So I want to lock my values that remain same. To lock your values, what you're going to do is insert a $sign before and after the alphabet of the cell name. Similarly, I'm going to place a $sign before and after the alphabet of the cell name. Now I'm going to click enter. So this is my standardized observation value, or the Z value. Now what I'm going to do is click on my cell, and I don't want to waste my time writing this formula over and over again. I'm just going to use the autofill function over here, take my cursor here, and on the right bottom corner of the cell, click and drag. And I'm going to drag till my data, corresponding data values. So I'm going to release my cursor, and now see all of my values have been given just like that. Now, if you'd notice, my values are in 3 decimal place, and it's because I had adjusted my mean and my standard deviation. And if I were not to adjust my values, then my Z values would have been in a bigger decimal place, like maybe 7, 8 decimal place. Right. Now, once I'm done with that, standardizing my values, I'm going to find out how they would be distributed on a normal distribution curve. So again, with the function equal to norm dot S. Now here's the thing, we have a couple function suggestions over here from Excel, and this norm.dist shows that it returned the normal distribution for specified mean and standard deviation. And I know my specified mean and standard deviations are these, and I really don't want these. I'm standardizing my curves. So my values are going for mean is going to be 0. So I'm going to go for dot S dot D. And now over here, it reads that it returns a standard normal distribution, has a mean of 0 and standard deviation of 1. And this is exactly what I'm looking for, because I've already standardized my values over here. And I also know that my mean is going to be 0 and standard deviation of 9.85 is going to be 1 equal to 1 standard deviation. So I'm going to go with this formula. So I'm just going to complete this formula. So it's norm.s.dist, open parenthesis, and it says take your z value. So it gives you the format how you want to write down the values. So it says in parentheses, give your z value. So my z value is this, and then comma, cumulative. Now I know that in a normal distribution curve, the y-axis have the probability density. So I'm looking for that function, and that is there with the false option. So I'm going to click on that. Now I've got the false. I'm going to close my parenthesis and click enter. So now that is my distribution value. Now really easy. I'm going to select this cell, right bottom corner. Going to take my cursor. It's going to become this bold plus sign. I'm going to click and drag all the way down to the corresponding values that I need and release. And this is my distribution value. So now I've got my z values, I've got my distribution values, and now I'm going to generate a curve out of this one. I'm going to select my rows and columns that I need. Go to Insert tab. Under Insert tab, select Recommended Charts. And this is recommending me charts. I'm just going to click OK for now. So it shows me a curve, but this is not really an area curve, because we know that normal distribution curve has an area of 1 under the curve. So I'm going to go to change chart type, go to my area option and select this chart. Okay, it's somewhat better, but like maybe I just want to see it as a line chart. Yeah, so I can change this, all of these. I have tons of functions over here. I can even change the chart type. I can make it a line chart and click OK. And now I'm going to place this properly over here. Take it a little down there. And maybe adjust its size so it's easier for us to see. And voila, there we go. That is my normal distribution curve. Now, obviously, this data was standardized and everything, and the chart that we've got is not a really smooth curve, but that's okay, because what we were looking at was an ideal normal distribution curve. And a lot of the times data do not tend to be the ideal normal distribution curve. However, this still is a normal distribution curve, and we're happy with this, and we can use this data to do a lot more calculations to find out the number of people within 1 standard deviation, the number of people within 2 standard deviation, or go in reverse pattern and see how many standard deviations would include like 50% of the population. So that was about it. Hope you enjoyed this. I know it's a bit of a work over there, and there are new formulas and functions to remember, but once you try doing it on your own with your data set 2 or 3 times, it'll stick in your mind and be really easy to operate from there.
Thank you so much for watching. Feel free to comment below any questions.